Second problem. Find the eigenvalues and eigenvectors of the matrix A equals to 3, 2, 2, 1, 2, 2, -1, -1, 0. 3 rows, 3 columns, 3 by 3 matrix. Once again, you consider that matrix A equal to 3, 2, 2, 1, 2, 2, -1, -1, 0. First step of the matrix problem. Characteristic matrix A minus lambda I. I am writing directly here. Matrix A minus lambda I equal to matrix 3 minus lambda 2, 2, 1, 2 minus lambda 2, -1, -1, 0 minus lambda. A means you write separately A matrix minus lambda into identity matrix. After doing all those calculations, we are getting characteristic matrix, this one A minus lambda I. Now you consider the determinant of this characteristic matrix. It becomes characteristic equation. Characteristic equation equals to determinant of A minus lambda I equal to 0. Determinant of 3 minus lambda 2, 2, 1, 2 minus lambda 2, -1, -1, 0 minus lambda equals to 0. From the formula, you can expand the determinant. Lambda cube minus C1 lambda square plus C2 lambda minus C3 equal to 0. C1 equal to sum of the minors of principal diagonal element in the matrix A. Now 3, 2, 0 are the principal diagonal elements. Now you add all these elements. 3 plus 2 plus 0 equals to 5. Therefore, C1 equal to 5. C2 equal to sum of the minors of principal diagonal element. Means minor of 3 you calculate separately, minor of 2 and minor of 0. Minor of 3, after deleting first row and first column, 2, 2, -1, 0. Determinant of these elements plus minor of 2, delete the second row, second column, then determinant of 3, 2, -1, 0 plus minor of 0. Minor of 0 means third row, you delete the third row, third column, then determinant of 3, 2, 1, 2. After calculation, 2, 2 into 0, 2, minus into minus it becomes plus, 2 plus 2 plus 3 into 2, 6 minus 2. That implies 2 plus 2 plus 4 equal to 8. C2 equals to 8. This is nothing but sum of the minors of principal diagonal element. C3 equal to, formula is determinant of A. You enter this matrix in scientific calculator. From that calculator, determinant of A equals to 4. Directly we will get it. Now substitute all these values in characteristic equation. After substitution, characteristic equation becomes as lambda cube minus 5 lambda square plus 8 lambda minus 4 equal to 0. Now you enter this equation, cubic equation, in scientific calculator. From that calculator, lambda equal to 2, 2, 1. We get these values are the eigenvalues of the matrix A. Now you observe one thing. In the last problem, in problem 1, I got 0, 3, 15 are different eigenvalues. Now here lambda equal to 2, 2, 1, repeated eigenvalues. Now for repeated eigenvalues, you follow the method, echelon form method, while to find the eigenvector. Case 1, let x1 equal to x1, x2, x3 which is not equal to 0 be the non-zero vector corresponding to eigenvalue lambda equal to 2. such that matrix A minus lambda I into x1 equal to 0. A minus lambda I, once again I am writing that matrix, characteristic matrix, 3 minus lambda, 2, 2, 1, 2 minus lambda, 2, minus 1, 0 minus lambda into vector x1, x2, x3, 0, 0, 0, 0 matrix. Now you substitute lambda equal to 2. After substituting lambda equal to 2, directly we are getting here 1, 2, 2, 1, 0, 2 minus 2, 0, 2, minus 1, 0 minus 2, into vector x1, x2, x3 equals to 0, 0, 0, 0 matrix. Now, previously I solved this system by cross multiplication method. Now I am solving by echelon procedure. I discussed echelon procedure. Now, in 3 by 3 matrix, second row first element is 0, third row first two elements are zeros, then the matrix is in echelon form. We can say that the matrix is in echelon form. Now, this matrix, it is not in that echelon form. By using row transformations, you should make that matrix into echelon form. The second row first element is 1. Now you should make that one as 0. Right? R2 changes as R2 minus R1. Now in the third row first element is minus 1. Then you should make that one as 0. Then R3 changes as R3 plus R1. These are nothing but row transformation. Now first row I am not doing anything. For the first row 1, 2, 2, 1 minus 1, 0, 0 minus 2, minus 2, 2 minus 2, 0. Now R3 changes as R3 plus R1, minus 1 plus 1, 0, minus 1 plus 2, 1, minus 2 plus 2, 0, into vector x1, x2, x3 equal to 0, 0, 0. Now the above system, now you observe this system, again it is not in the form of echelon, right? Now if you are converting the third row second element as 0, then it becomes into echelon form. For that purpose, you should use second diagonal element only. These are nothing but rules of row transformation. R3 changes as, now it is 1, then you multiply with 2, 2 into R3 plus R2. Then first two rows are same, 1, 2, 2, 0, minus 2, 0, 0, 0, 0. Here 2 minus 2, both are zeros. I am writing directly 0. x1, x2, x3 equals to 0, 0, 0. Now multiply, after this is in echelon form, second row first element is 0, in the third row first two elements are zeros, the third element is 0, don't bother about that element, only two elements, first two elements only, I need first two elements zeros. Now you multiply this system, first two matrices, first row first column x1 plus 2x2 plus 2x3 equal to 0, then 0 into x1, 0, 0 anyhow, I am writing here 0 x1 minus 2x2 plus 0 x3. Now third one, in the third row all elements are zeros, no need to multiply, anyhow it becomes 0. From the second equation x2 equal to 0, anyhow these two are zeros, minus 2x2 equal to 0 means x2 equal to 0. x2 equal to 0, you substitute this value in the first equation. In the first equation becomes as x1 plus 2x3 equal to 0. Now here one equation is available, you have to calculate two variables x1 and x3. For that purpose you should consider from last x3 equal to k, choose x3 equal to k. Therefore it becomes as x1 plus 2k equal to 0, x1 equal to minus 2k. Now I got x1 equal to minus 2k, x2 equal to 0 and x3 equal to k, already I have taken. Now this is the procedure to solve the system of linear equation by echelon form. Now substitute all values in the first vector x1 equal to x1, x2, x3 equals to minus 2k, 0, k. K is common, minus 2, 0, 1. This is the first linear independent vector corresponding to lambda equal to 2. x1 equal to minus 2, 0, 1 is the eigenvector corresponding to lambda equal to 2. Now case 2. Let x2 equal to x1, x2, x3 which is not equal to 0 be the corresponding to eigenvalue lambda equal to 1 such that matrix A minus lambda I into x2 equal to 0. Once again I am writing here matrix A minus lambda I, that is 3 minus lambda 2, 2, 1, 2 minus lambda 2, minus 1, minus 1, 0 minus lambda into vector x1, x2, x3 equal to 0, 0, 0. Now first two eigenvalues are repeated. For the repeated eigenvalues only we are following echelon form procedure. Now the third eigenvector is lambda equal to 1. It is different, only one unique eigenvalue is there, right? For that one you solve by old procedure, cross multiplication method. Now after substituting lambda equal to 1 in the above system, it becomes as 2, 2, 2, 1, 1, 2, minus 1, minus 1 and 0 minus lambda means lambda value 1 minus 1 into vector x1, x2, x3 equals to 0, 0, 0, 0 matrix. Now you multiply first two matrices, first row, first column, 2x1 plus 2x2 plus 2x3 equals to 0. From the second row, first column, x1 plus x2 plus 2x3 equal to 0. Minus x1 minus x2 minus x3 equal to 0. Now you observe, you should not consider first equation and last equation. From the first equation if you are taking 2 common, the equation becomes as x1 plus x2 plus x3 equal to 0. From the third equation if you are taking minus common, x1 plus x2 plus x3 equal to 0. Means both equations are same. Means we cannot solve 3 variables from one equation, right? Now you can take first and second, otherwise you can take second and third one, right? Now I am considering first two equations. Once again I am repeating here. If you are taking 2 common, x1 first equation becomes as x1 plus x2 plus x3 equal to 0. From the third equation, if you are taking minus common, x1 plus x2 plus x3, both equations are same. That's why you should not consider these two equations. Now you can consider first and second. Now I am considering first and second. The same logic. In the first equation if you are taking 2 common, x1 plus x2 plus x3 means every coefficient is 1. Now I am writing coefficient of x2. You start with middle term 1, next term 1, next term 1, again last one is 1. Now from the second equation, what is the coefficient of x2? 1. What is the coefficient of x3? 2. Coefficient of x1? 1. Once again you write the first element. Now you do the calculation, determinant of first 4 elements, x1 by 2 minus 1 equals to x2 by 1 minus 2 equals to x3 by 1 into 1, 1 minus 1 into 1, 1 minus 1, 0 equals to k. x1 equal to k, x2 equal to minus k, x3 equal to 0 into k. Now you substitute all these values in the second vector, x2 equal to k minus k, 0, k is common, 1 minus 1, 0. This is linearly independent vector. Therefore, x2 equal to 1 minus 1, 0 is the eigenvector corresponding to lambda equal to 1. Eigenvalues of A are lambda equal to 2, 2, 1. Eigenvectors x1 minus 2, 0, 1 and x2 equals to 1, -1, 0 corresponding to eigenvalues 2, 2, 1 respectively. Now one important thing you have to observe, in most of the problems for the repeated eigenvalues we will get at a time 2 eigenvectors. For this problem I am getting 1 eigenvector. Observe this one, lambda equal to 2, 2 means at first when you are calculating eigenvectors corresponding to lambda equal to 2, at a time x1 and x2 will get it, but here I am getting only one eigenvector, means for 3 eigenvalues are present but we are getting 2 eigenvectors. This is different case. Now important problems on eigenvalues and eigenvectors. These are the 4 problems. Frequently they are asking this type of problems.